Thank you. Also, thank you, Bill. Yeah, crowdsourcing the software architecture is a topic that I will be talking about. Bill introduced it quite good, I think. It's when we look at the schedule today, it's not the first talk to reference an architectural discipline that is not really isolated or put into the hands of one guy. The one thing that makes this session better than the rest is that I will be handing out money. So will happen later on, so you have to stay for this. So before that, I will bore you to death, I swear. I'm more eloquent and also funny in my mother tongue, in German, or if you ask Germans, my mother tongue is Austrian. But it's kind of the same thing. Whatever your impression of this talk is, just add another 20% or something to your evaluation of it. This would happen if I would be speaking in German. So when we talk about crowdsourcing, the foundational idea is that we have a cross-functional nature of software development. This is a concept that is not new. It's been there for the last 2 centuries, I guess, where we don't have these silos of people working on software. We don't have an analyst, an architect, a developer, or even architect and designer separated. We have a build engineer and operations guys that are all separated into different teams. But we have what I call the crowd. And this is a crowd, and you put a problem into the crowd and you get a solution out. And it's always easy on paper. It's just make it cross-functional. And if you ask question how, then ask the team or something. Happens normally. So it's always a little bit too easy, I guess, when people talk about it. We have a whole trends like DevOps or something that tries to bring the build and operations side and development side together. We don't have such a trend for architecture in reality. Some of the microservice hype it also covers that architectural ideas are more distributed among teams, but it's predominantly a technical trend. So I want to talk about this in more detail and perhaps in a little other fashion that you heard it before. All of these things that I will present here are from my own experience. It's not some theoretical stuff I sucked up in the internet or something. I've been working in HR projects for over 10 years now. It's as a consultant, I consult various teams, so it's perhaps about 40 projects that I tried to convince that HR is a good idea or convince that architecture is a good idea, whatever team I'm in or which side they're coming from, and put these two topics together actually. So we have lots of stuff going on in these projects. I will not show you in detail everything that we did in this project, but I will try to get some concepts out of it and try to talk about these concepts. So the first thing is why even talk about crowdsourcing architecture? What's the purpose of it? So you're here, so perhaps you have a purpose in your head, but it could also be that you're just frightened by the idea, and so you're here so that you can just put it away. So I was once in a project, and in this project there was a guy talking about his architecture role, and his architecture role was in a team, and this team was within a project that was 150 people tall, had some guys in India, some guys in Germany, and tried to bring it all together. And he had a nice metaphor of describing how the project works, actually. He said, well, the whole project is actually a train. And everybody rides on this train. There's developers in this train, there's analysts in this train, requirements guys in this train, there are people doing operations in this train, and they're having a party. And actually, we're the architecture guys, we are sitting on horses and riding besides the train, trying to keep up. We try to see through the window if there is something missing in there. So do they need food or something? I don't know. Do they run out of gin or so? So that's why we tried to, that's what they tried to figure out. What are they missing? So they looked ahead and said, oh, there are some rails missing. So perhaps they throw in some rails that the train can keep going. They they change the switches accordingly and stuff like that. And the people in the train aren't really interested in this stuff. They're just, well, they're having their party. Everything is fine, you know. But if something happens, if something is going wrong with the system, the first thing they ask is, well, is it functional? If it's functional, it's our problem. But if there is something with performance, scalability, security, or whatever, just ask the architects. So they're not really caring about the topic, but when something happens, then they're pointing, finger pointing in this direction. And this is a setup that is not that uncommon, I would say. It's only one reason where I think that architects that are isolated in their responsibility for quality of the system aren't such a good idea. If you have technical guys working on the project, developers most of the time, then I would guess that these developers shouldn't be able to say we did a great job if the system doesn't work, or if the system isn't secure, or if the system doesn't scale. They didn't do a great job. Everything they do is, well, details, as Kevin Hene said this morning, and these details matter for the quality aspects, and they should care about them. Okay, so the second thing, so the train story is the one thing that I experience in projects. The other thing is more a theoretical standpoint. I was working on a book that I published in 2013. It's also German, so don't bother Googling it. There I talked about agile architecture in a greater more detail, and one research topic was the architect as a role, and I got several books here. Okay, and all of these books have some idea about software architects in them. It's no quality aspect that they're listed here. They're of varying quality, I would say. Some of them pretty great. You know which one I mean. And there are some aspects of a software architect that they actually describe. They describe the character of a person that actually is a software architect. They describe the know-how that such a person should have to be a software architect. And then they describe duties. So what should a software architect actually do? And I compiled a list of words or character, know-how, and duties that at least 2 books mentioned. So it's not a one-off thing or something. And I came up with several character describing things here. So we have, as an architect, someone with courage, accessibility, empathy, patience, diplomacy, ability to abstract, good verbal skills, imagination, receptiveness, passion, mutability, authority, sense of proportion, flexibility, diligence, capacity of reaction, good analytic skills, and so on. So the classic IT guy.
What's that one over there?
Hmm?
You can't read that one.
Ah, so I forgot to mention one. So it's the understanding of processes. So yeah, perhaps I couldn't translate it. So okay. The second thing is the know-how that I looked at. So we have risk management, we have enterprise strategy, time management, project history. He should know the company, of course, decision methods, strategic and dynamic code analysis, implementation techniques, architectural concepts like patterns, practices, quality attributes, and so on. All relevant technologies, but not only on a superficial basis, but in depth, and programming from actual doing stuff. So we don't get an ivory tower architect. So now we have this great guy who knows all this stuff. And now you should ask, why is he working for us? He could work everywhere. Yeah, it's pretty hard to find these guys. And when I talk about distributing the architect, I don't say that we now need 15 guys of this caliber. It's more of a different approach that we'll see in a short time. But still, there are still duties. So let's assume that we all in this room, we are architects that all fit this description. We still have lots of duties here. We have to pass on know-how because we are the ones that have it. We have to network, we have to mentor, we have to coordinate, we have to model, we have to give context, motivate developers, present the architecture, communicate with stakeholders, influence the company's strategy, integrate and test solutions, develop spikes, form teams, make decisions, specify quality requirements, and so on, and implement, of course. So all of these duties, now you have this great guy, and you packed him with duties, and I guess it's kind of an overburden for a guy, and he will leave the company shortly afterwards. But in general, less dogmatic perhaps, you may stand a better chance of finding a group of people that fit this description than one guy. A group of people that has this know-how, a group of people who has this, who is able to fulfill these duties. You're quicker in reaction time if you have more people that can react. We often hear the term bottleneck referring to an architect, and actually that's the one thing that gets you off the train. If you're the bottleneck, people work around you, and shortly after you're out of the train and trying to ride besides the train, trying to keep up with what's happening. And you normally get a better system if developers think that architecture or technical problems that are associated with quality are their problem too. So there's no finger pointing, but sort of accountability to developers. Amazon always states that nobody takes care of a problem like the owner does, which is pretty true for architecture too. If we have an architecture that is owned by a specific group or specific person, the other guys don't care that much. So that's another reasoning, which is more theoretical, why we need to think about, or we should think about cross-functional teams or distributing architectural work. A third one comes with agile principles, which is kind of redundant to the topics I already stated. So agile principles, just 3 of them mentioned here. Build projects around motivated individuals, support them and trust them. And what does trust mean? Trust means that you trust people getting the job done. If you say developers, well, I trust you that you develop a great solution, but not the hard parts. This is architectural work. If the significant parts, the one that matter, the one that are expensive or significant in change cost, these are not the ones you're responsible for. It's not a real idea of trust, I would guess. What we need to get developers is support. And that's another idea of an architecture owner or an architect that I will introduce also in this talk, where we have a supportive function to actually support people that are not up to speed or not that good in making conceptual ideas work. The second principle is that continuous attention to technical excellence and good design enhances agility. So if we have technical excellence, or we want to have technical excellence, we need people interested in technical excellence. But why should I be interested in technical excellence if I can't decide anything? Because another guy is deciding it. So it's a bit of a chicken and egg problem there. Most people say we can't do crowdsourcing stuff with the architecture because our people are not knowledgeable enough. Well, they are not knowledgeable enough because it's of no point or no reason to be that. The last thing is that best architectures come from self-organizing teams, which is pretty self-explanatory. It's more of the cross-cutting idea that I already mentioned. So when thinking about crowdsourcing, I have various reasons why to think about it, and this is just a summary from the things that I just stated. Normally, you get more realistic concepts out of people that are actually working with the software. You get broader know-how, you get better motivations, better motivation out of engineers. You get faster reaction times and so on. So these are the reasons. And of course, there's a but, or there are challenges. That's the first thing I want to talk about right now, because now I have the skeptics in the room. We have challenges and risks here, and I want to pick two of each in this talk. One is, how do you get an initial design for an architecture out of a group? It's a hard thing to do, to get a conceptual idea that is highly well, that is good, actually. That is okay. I'm missing the word that I like a particular German word. Coherent. Yeah. Coherent is pretty close enough. So a coherent initial idea out of a broad group of people is kind of designed by committee, which is not a favorable part, I would imagine. So this is one challenge. The second challenge is distributing the ongoing architectural work. So if you have an initial design and then you say you work iteratively on the architecture, which is something you want to do in a distributed environment, then how is this distributed work on the architecture going in the right direction? These are two challenges, and I will spend most of the time in the second challenge here. The two risks are something like conceptual integrity that is often lacking in such environments. I want to talk about that. And the second risk is that people often throw in that it's a wasteful process. So it would be so much easier to have just a guy deciding how it should be, and then everybody doing that. It's faster. You could argue in that direction, and I will talk about this risk of losing some of these efficiencies in a distributed environment. Let's start with the initial design. So some people argue that agile projects don't actually care about initial design, which isn't true. If there is not an initial design, they at least have an idea, an implicit idea, how the architecture should look like. Perhaps it's the third installment of a product line or something they're building, so they have an implicit knowledge of what the architecture should look like. If you don't have something like that, you need a phase or a sprint or an iteration where you build this initial design. And initial design is something that I want to describe with various concepts that are important to me. One is the Twin Peaks model, and it's kind of old. It's, I think, from 1987 or something, so in close proximity to the TV show. So the name is no coincidence, I guess. We have the requirements and the architecture peak, and the idea is that you are most efficiently and have a better project if you work if you spiral your way down to more detail in a collaboration between these disciplines. So you want to have a requirements and an architectural view. If it wouldn't be the 80s, but the 2010s where we're talking about, would perhaps be a triple or quadruple peak where we have development and operations or something in there too, in a feedback loop that has a real business impact. But what we try to have in an initial design is that we have a view of the requirements. So what is the product vision? What are the goals that we are trying to achieve? What are the quality attributes that we want that we need to design for? This is something that Conrad, I think, from Evato, he called that project docs, I think, where he said this 2 to 6 pages where we say why do we build something. This is something on the top of the requirements peak. Then we have an architecture peak, and normally we can say that high-level architectural design decisions are only based on high-level requirement ideas. So if you have a high scalability web shop you build, you probably look in a certain architectural direction that is happening in a different room called microservices right now. And if you have not such scalability needs, then you perhaps look in another direction, because the whole deployment and monitoring stuff is a little bit frightening too. So you get these top spots from these two peaks, and normally we put it in a document that we call architecture vision, which has the requirements part, so the what, and the architecture part, the how, on a very on an initial basis. And there we put in the system boundary, the important constraints, quality attributes, perhaps some important quality scenarios or some risks that we see in the business. In the how, we put some technologies that we see, architectural style perhaps, so the predominant architectural pattern that we use, the architectural principles, perhaps a sense of a high-level structure or a domain model. All of these things are here as an idea after the initial design, not as a irreversible decision. So Kevin Hennay said today that architecture is a hypothesis, which is kind of what it is. It's a hypothesis where we start digging deeper. And this digging deeper is something that should happen in a risk-oriented way. So we say, which of these parts are something where we have like a little bad feeling in our stomach because we never did it before, we never used that technology, we never actually used that style of an architecture before. So these are the things you want to get first when you go into implementation, and none of this is fixed. So this idea of not fixing things, but to go into a slim implementation of things is also called a walking skeleton, which is not part of the initial design, but actually a walking skeleton is an agile idea that you touch many parts of the architecture very early in a slim fashion. So you try to put together the main architectural components you have and try to see if this all fits together, if your idea actually works on an initial level. And how could you do that if you don't have an initial design? If you don't have an idea about your architecture, you can't actually do a walking skeleton of it. So of course every project has some idea or initial thought how the architecture should look like, and this is called initial design for my purposes here. So what about distributing it? I would actually not distribute it, that part. Most of the time we work with Tiger teams, which is something that actually came out of NASA. But they put together some experts from different fields and tried to put together a working concept that wouldn't be possible if you distributed it just to one team or one chapter in there. So you bring together specialists from different sets that have different sets of expertise, and the team is broken up after the task is done. Essentially, that's the concept. We also normally try to build a team around this initial design for a product, where we say, try to figure out what different sets of expertise we need. We try to bring together these people. We formulate a vision, and we try to make it powerful and also accepted. The accepted part is very important, so we try to get people to actually understand the vision, give feedback to the vision, and then we try to integrate the people that worked on it into the different teams. So every team should have somebody who actually worked on the initial vision, not only to represent it, but also to see if the vision actually works or if it needs update or changes on some points. So this is kind of a not really distributed way of thinking about it. We have a small team developing it, and then we kind of spread the idea, and then we start the process with ongoing architectural work to change it where it's necessary. And that's why I spend more time in this ongoing architectural activity, because this is the thing that changes the initial design, perhaps, and also makes a working architecture that comes from potentially more people. If we look at this ongoing architectural activity, I want to start by splitting up architectural work into several tasks. And I do this by using a concept from Colonel John Boyd. This one is older than me, so pretty old. I used to be young, but now not so much. So we have this cycle, OODA. I don't know, does anybody know this one here? Okay, one guy. So, okay. So somebody talked already about it. So it's more of a point. Sometimes the DevOps guy just think it's a great idea to look at this cycle and go through it quicker. What I want to do right now is to split up architectural work into these topics, because some of them are harder and some are easier to distribute. If we have this observe, orient, decide, and act cycle, we can say that architectural work is actually comprised of observation, so recognizing potentials, risks, or problems. So where does our architecture not fit? Where do we run in our problems because a concept is missing or not correct? Then we need some orientation phase where we can design or evaluate options. So this is the creative part. We can decide which option to use, which is very interesting that we separate these two things, because the actual design for something is very hard to distribute. The decision, do we do it, is something where there techniques exists, where there exist techniques where people actually are involved into a decision-making process. So this separation is kind of interesting. And then we have the act part, which is more the implementation or the doing, the operative part of this thing. So if we look at these things that we do in architectural work, then I want to go through them. So observe, orient, decide, and act, and describe concepts, how we distribute or how we work in this sector of architectural work, actually. So the observation part is something where we need people being aware what the architecture is and where we have problems. This is something where we need the responsibility of architecture within the teams, and if we have that, it's pretty easy that people come up with problems or things that are disturbing for them, perhaps, or destructing their idea on a detail level or something. Then they come up with problems on the other part. So we have more eyes. It's even easier in a distributed environment, this observation part. The second thing is that we need somehow an architectural awareness. So what is the architecture and what work needs to be done? This architectural awareness is sometimes not there in pure Scrum teams. I don't know if you work pretty often in these environments, but Scrum teams are very often set up the way that they try to put features out there as much as possible. So it's always features, and the architectural ideas behind them get lost a little bit because there is no driver for it. The product owner is most of the time also functional, even if he could be somebody who is interested in the quality of the product too. Most of the time it's the functional requirements that he wants to get out of the system predominantly. So this architectural awareness is a central part to get architectural topics to the people. Then we have something like testing for quality attributes. When we have quality attributes that we state in the initial design, so we say that scalability is an important issue, we should have some tests that say if we are scalable or not. If we're scalable, the team did a great job. If you're not scalable, team didn't do a great job. So this sense of accountability that is produced with this kind of non-functional tests is something that is very important. People like Netflix were the first that actually did it on a broad scale with their Simian army, trying to make system parts fail so that they can actually see that the system is able to recover and has better reliability, essential part. So when we have reliability, we don't state we need a reliable system, but we also have a test that makes people accountable for it. And the third part, where we recognize risks or problems, is during recurring evaluation workshops. We get feedback from the work that has been done, and we also get people to present what they actually did. I want to go into details with two of these. So the second and the fourth is something that I want to go into detail. The testing and the first part. The first one is pretty easy. It's more of an organizational stuff. The third one is something that should fill in an extra talk, perhaps, or something. The other two I will explain in a little bit more detail. Eltio? Please. We have 90 minutes, so please into action.
Okay. So I had an observation or a question about the second one, but you say you are going to go into more details about that.
Yeah.
So I'll wait.
Okay. So I have 4 slides on that one, and if it's still there, the question, then I come back to you, okay? Okay. So the second one, architectural awareness. What I try to make developers realize is that their work is not only comprised of implementing source code, but also about thinking about architectural outcomes of this work. So what do we actually do if we put this few lines of code in there? We bind in an external library, we have a dependency there, or we have a distributed concept now, we have something asynchronous going on right now. So this is something where we introduce new ideas and we have to figure out what the consequences are. So most of the time in Agile projects, we have prioritized requirements and we try to implement them. So we have an implementation cycle. And this implementation cycle is just something where we build code and ship it. And this is where value gets generated. So we want to spend the most time in here. On the other hand, we have an architecture cycle that isn't something that delivers value directly. So it's more of a risk mitigation strategy. We have some requirements where we don't see that they fit in very nicely with the work we've already done, where we need new concepts, new technologies, where the technologies don't fit, or we have blank spots on our architectural side. So we have some requirements that belong into this architectural cycle. And these two cycles are pretty important to Agile teams that work on requirements, because most of the time they spend their time in here. And the implementation cycle is where we sit in front of the IDE and we code. And some things work and some things don't work with this mode of operation. In this mode of operation, we have a direct problem solving stuff going on. This direct problem solving is focused, what is happening in there, we can analyze very focused. So we have fast decision making. We're good in finding a local optimum. So this is everything where we directly work with a problem at hand. We have our IDE open, we have a problem, and we work. What doesn't happen, or what isn't very good in this mode of direct problem solving, is synthesis. So putting things together, actually a strategic thought or abstraction. These are things that are very hard in this mode of operation. And most Scrum teams work in this mode of operation for 2 or 3 sprints, and then they need to do a refactoring sprint, or a sprint where no value is added at all, because they need to rework everything that they did. So this mode alone isn't enough. And if we have non-trivial problems like high quality requirements, high scalability, high performance requirements, complex trade-offs within our requirements, restrictive constraints, many options to choose from, many stakeholders that are involved, or many teams or system parts that are affected from the solution that we build, then we have typically a point where this direct problem solving isn't the best idea. Rick Hickey, the man behind Clojure, the programming language, he always says that great insights don't come from permanent low-level activity. He has concept named hammock time, where he says he steps back from the problem and just lays back into a hammock. I don't know if he has such a thing at his workplace, but he just steps back, does nothing, and when he comes back, he at least has the guts to throw something away, which is sometimes a good idea. So we step out of the process of direct implementation and do something else. And this is actually something where we step into another cycle. So the architecture cycle is something where we have not direct implementation activity, but where we have some conceptual thoughts. And good teams do this very often. Not once in an iteration or something, but with every task they step back and, for instance, define the problem. So what problem are you trying to solve? And this is not as easy as it sounds. It's not like we have this function that we need to implement, or we have this UI text fields that we have to implement. But what is actually the problem that we're trying to solve? Is it something that needs to be scalable? Is it something that needs security aspects to be juggled? And so on. So the problem on a broader basis, which constraint actually rob us of some important options that we have. These are things that we can think through, and normally it gives us a better idea what to implement. Then we have this hammock time, or if we say we step back and think for a minute, it's also a good idea perhaps. We can talk to others, sharpen our vision. We sometimes in our projects have a rule that you don't directly go to another developer and talk to him about the problem that you have, but we have this rubber ducking in between. I don't know if it happened to you, but if you explain a problem to another person, most of the time not most of the time, but sometimes when you explain the problem, you already get the answer yourself. So you're going to another level of abstraction when you're talking about the problem, and that alone is something that helps you. And rubber ducking is something where we have a rubber duck sitting on the top of the screen, and you explain the problem to the rubber duck. And if that doesn't help you, you go to a fellow developer and ask him. So this is something, it's called rubber ducking. It's not an idea that I had, but some people at a project that I worked in had that idea. So there is not too much of a communication burden going on. So we can externalize ideas, we can experiment in another environment with certain problems that we have. We can abstract or externalize ideas. We can learn, Google it, whatever. It's also not coding, and it shouldn't be Stack Overflow driven development or something, but it could give us some broader sense or broader ideas, and we can analyze or criticize our own solutions, or perhaps solutions that we built in the past. And all of this is the foundation on which distribution of architectural work actually works. If people don't do this on an implementation level, then it's hard to put responsibility in their hands, because they would just implement something and don't care about the architecture. If teams do that on a regular basis, or work, or this is something where they say, well, that's not architectural work, that's implementation work. That's great. If they say that, then they have a sense that architecture is their problem too, or the problem to solve is their problem too. And this is something that I find a very important basis to actually think about distributing.
Yeah, so my question was about the event horizon of the team. Because usually the event horizon of the team is determined by what's in their backlog.
Yeah.
And the backlog is usually filled by the product owner or whoever, where it comes from, with what Christian would call green stuff. Mm-hmm. Things that have direct business value. And what you're saying with the left side, I like the two loops very much. And the left side of the loop, actually what you're creating there is yellow stuff, and maybe a little bit black stuff in Christian's terms, yeah. Meaning things that has indirect business value, enablers, etc. Yeah. The problem here is that there is a time dependency between the enablers and the green stuff. So if the team looks at, has hammock time, it looks at the backlog, but it only sees the green features, it's probably too late to start thinking about, oh, wait a minute, then we have an architectural problem. Now we have to define the architectural solution to that. We have to create a new architectural component that actually has to be added back into the backlog, and all the time that feature cannot be built. So there's a timing discrepancy because of that dependency. So the event horizon of the team being, doing its daily job is too small or too close. Let's put it that way, to actually identify with enough anticipation the architectural backlog items that need to be added in time. So I think with the hammock time we have solved this partly, but I don't know if you recognize this.
So the architectural awareness also includes that a purely functional backlog is not not representative enough of the architectural tasks that are actually there, so that the team is a little bit too narrowly focused. Is that? So
well, it's the event horizon. It's how far ahead can you look.
So okay, so how far? I'm just repeating it for the microphone. So how far ahead the team can look is something that is somehow constrained by the things that are in the backlog, and that's why I will talk about the things that are in the backlog in a few minutes. So this is also something that is a problem of ours, and we try to put things into the backlog that represent architectural work more than only functional things or green things. Okay, I've heard this 3 years ago about this yellow and black stuff, and so yeah. Okay. Okay. So which time slot? So that we have the commercial break. Yeah. Okay. So. The fourth thing that was presented on this slide was the recurring evaluation workshops, and I want to have a short look on that one too. These evaluation workshops, I know that there's a big community here that knows how this works actually with ATOM and all the big methodologies. Actually, we do this kind of evaluations in an ATOM sense too. What we try to do here is to make them smaller so that we can do them in every iteration, every second iteration. Normally we start with the idea that we do a 2-hour session every second sprint or every second iteration. So we have a 2-hour workshop where everybody comes, and we try to do something like bringing awareness to what architectural activity were going on and giving feedback to them. So what we are trying to do in these workshops is that we look at the big picture. We look at the thing that we develop perhaps in an initial design phase, or where we have an idea of how the architecture actually looks like, and we say, okay, in the last 2 iterations perhaps or something, were there any changes to the architecture? Did anything change? Did the technology change beneath an arrow that we painted in here? Did we split the components? Did we change an interface or something? In which parts where architectural activity is going on are any new risks that you see? This is a part that is not normally in an ATOM evaluation, because an ATOM evaluation can happen 2 years after a project is has started, and you can't reflect on 2 years of work. But if you're doing recurringly in the iteration, it's something where you can look at too to find important topics. And what we do here is that we just get architectural topics that people worked on. The second thing is that we look at the requirements side and do the same. So this is a task board actually from a project in Malta, where well, they tried to make it work that way. What we have here is some tasks that they worked on, and we ask questions: which tasks were done in the last 2 iterations that have impact on others? So which tasks did not only affect you, but have potentially an effect on other people? Has anybody worked on a quality aspect? So not a functional part of the system, but a quality impact. So something for authorization authorization service or something performance improvement or something. So this is something that is normally a little bit more cross-cutting than functional requirements. So we put it in as a topic too. And then we ask directly for cross-cutting requirements. So any requirements that are more cross-cutting. And this gives us, these two things gives us topics. And these topics are prioritized then. So we have sticky points that people apply to these topics. Then we say, well, two of these topics have some points on them, so probably we should talk about them. It's the same variation that we get from ATOM workshops too, where a little portion of the problems or scenarios in this case get lots of points, and then lots of scenarios get 0 or 1 or 2 points. The 0, 1 or 2 point stuff is something that people can talk about bilaterally. In the workshop, we concentrate on the things that get lots of points. So perhaps this top 2 topics then. And then people can present whatever they did. So how did I work on this requirement? What was our architectural solution there? How did we change the system on this part and so on? And there, every kind of presentation is fair game. So some people just draw something on the whiteboard. Some people come with a screenshot from AppDynamics and show how memory problems were bad and what they've tried to fix and so on. And this is it's an evaluation in the sense that we try to figure out if the solution that is presented is not only feasible for the small part it was developed in, but also for the bigger picture. But we also try to broaden architectural knowledge. To be a little bit more detailed, what happens in the discussions when somebody presents, we say that the presenter should state how the topic was handled, so which were relevant tactics or candidate decisions or whatever, and what constraints were there that made the problem harder to solve. This is something that we learned actually. If you let people present only what they did, and then directly people get into the question mode, then you get lots of defense. Yeah, we couldn't do that because that was the case and that was the case, and we had this constraint here, and that option wasn't available to us and stuff like that. So we introduced this question for the presenter from the top. So he can state what actually didn't work out pretty well or didn't work in his favor. On the other side, the people that are in the room for the workshop, they ask, do I understand the solution? Is there an aspect of the problem that wasn't tackled? So are there open point or risks in there? And are there negative implications of what they did? On a certain in a certain part of the system. This is more of a mapping of a problem solution that they present on my part of the system where I work at. So that gets us trade-offs or risks or things that get overlooked, stuff like that. And with these feedback mechanisms, we normally try to invite everybody that is in a project, and we have some scaling ideas about how these workshops get productive, even with a large crowd. So we worked with 40 to 50 people in such an environment that come to such a workshop. The brainstorming part and the vote part, this is pretty easy. The discussion part is very hard. So we try to apply some World Café stuff in there. And I don't know if you're familiar with the idea, but you have topics on different desks in a big room, and small groups working on these topics. And after a certain amount of time, you switch desks. So everybody sees every problem in the room, and normally one person stays put on the desk where the problem is discussed and tries to get the people up to speed that are new to discussing this problem. So you get lots of people seeing lots of problems. This is just one idea that we worked on that was working pretty nicely. The name is World Café.
Yeah, well, it sounds different now.
So this was one thing. The other thing that we tried were time slots, which works pretty great if not everybody is interested in everything. So, yeah. So the second part was the orient part, which is this design and the evaluation of options that we have. We have in here when we see the first point, the observation part that I talked about right now. This observation part is ongoing, and also solutions that already went through the whole OODA cycle are something that we need to observe. So that's why the evaluation part was in there for solutions that are developed in the second part of the OODA cycle. So in this design part, the creative part, we try that we try to have a process where not everybody is involved in designing one specific topic, but we have a small group of people or one guy designing something, and then presenting it to the group to actually decide which would be the next step in the OODA cycle. So what we try to do in the design phase here is to find somebody who would actually work on an architectural topic. And this is a task that is not present if you have an architect, because everything is put on an architect's shoulder. But if it's not, if he's not present, then you have to find somebody who actually does the work and tries to come up with ideas. So the one thing is that we have a problem-driven assignment of topics to a small group or individuals. This problem-driven assignment is normally a pull approach. So if you have a topic, the people that think they are good enough to do it or to tackle a problem, they usually get it. Then we have architecture requirements that are perhaps on an abstract basis only quality attributes broken down to quality scenarios, and we try to work with these because lots of architectural topics come from the work on these quality attributes, and that's perhaps something that gives that event horizon to teams that Elke was talking about. Then we have something like ad hoc workshops where we say if a problem isn't solvable by a pair of developers, then you can call in for a small workshop of an hour where people join you and try to figure out how it works. And then we normally install mentors for architecture or for individual technologies that we use, or specific quality attributes that we need to achieve. These are people that are more knowledgeable on this part, and they can support on this side. They are not the ones that are developing everything in there, but they can support this side. Here I want to talk about the second part, which is getting the quality attributes into a backlog or a list of requirements too. The mentor part for the architecture is something that we stumble upon when I talk about the alternative roles between a classic architect and the whole team doing it. So quality requirements, I think I don't have to talk about them much. They're not easily optimizable in retrospect. So if we build a system and then try to optimize certain quality attributes, we typically fail and build another system. We have quality attributes that influence high-level structure and granularity of our solution, and quality requirements are often cross-functional. So they affect many parts of the system or project members. So quality requirements are some of the most important requirements for architectural work, actually, and we try to use quality scenarios to break them down, which is also something that is pretty common, I think, in these parts. So some examples for quality requirements or quality scenarios, and I put these examples on here because they have a different nature how we tackle them. And this is not exactly the green, yellow, black approach, I think, but this is a way how we categorize quality scenarios to actually work with them in agile backlogs. The first thing up on top is that an algorithm for calculating articles' popularity is easily adaptable and exchangeable. So we have a website or a system that actually has articles, and they're voted in popularity, or some aspects get into an algorithm, and it is done. If we want to keep that exchangeable, it's, I don't know, what could we do? Perhaps we can isolate it from the rest of the application somehow. We can use an extensibility point or something where the algorithm is hidden behind. So the important thing is that it's directly connected with the implementation of the algorithm. So the guy who gets the functional requirement for implementing the algorithm also should get the notion that this algorithm that he's implementing should be exchangeable. So he can work on this thing the correct way. He can implement it the right way. So the first thing, the first scenario up here is directly associatable with a user story or with a functional requirement we have in the backlog. And normally in agile projects, this is called acceptance criteria. So this is also something that agile projects would find on their own, even if you don't think about quality scenarios. They would find some acceptance criteria to their quality requirement, to their functional requirements. The second and third part are something that are not are some examples that are not directly associatable with a user story. The second one, a user interacts with the platform as the assigned server fails. The problem isn't apparent to him even when he tries to navigate back to the previous user masks or continues in a complex interaction. So it's perhaps a little bit too detailed, but in essence, the user shouldn't know if servers are failing. This is what is stated here. Solution space, what are options that we could actually architecturally introduce? Redundancy, fallbacks, we have to look about session management, state, things like that. These aren't topics that are directly associated with one functional requirement we have in the backlog. Perhaps it's we could put it to every functional requirement we have, but mostly it's something where we need to think or design a solution on an infrastructure basis or a framework basis that we can then provide as a foundation for other people to build upon. And this work that needs to be done behind these tasks, behind this scenario, is an own task. So we put it in the backlog as is. The product owner understands it, so he knows when something in the infrastructure fails, how does it affect the user. Perhaps he needs to know how often that happens to have a business value associated to it, but normally this works pretty great, and we put it in as a separate story. The third one is a little different. It's also kind of same thing here, but it's more of an abstract thing. It's easy to find personnel for system maintenance and extension of the system, which is very abstract of a scenario. It's not the schema of the scenario, of course, but in a brainstorming, something like this comes up sometimes. And with this part, you have the problem that it's not a particular architectural trait you can implement and then this is settled, but it's more like all the solutions that you could imagine for this. Playing with, staying with standards, doing something that other people did already. So look at what ideas are spread in the internet, what are common things to do right now, and stuff like that. And every decision we make and every implementation abstraction level needs to be brought back here. So everybody needs to act on this. Everybody, when he makes a decision, try to stay with the standard. Try to stay with the common approach and stuff like that. So this is more of a principle that we want to describe after this scenario. And it's not the architectural work that is frightening. It's more the architectural work is defining the principle, but then there comes a long process of people working for this goal. So yeah.
So the first one is basically extensibility, right?
Yeah.
And then the third one.
Yeah, it could also be maintainability or stuff like that.
Those things are hard to measure with the quality attributes.
Yeah.
And so is there some handy way to actually validate that I'm achieving those things? I know how to test performance and scalability and availability, but something that's kind of squishy.
Yeah, of course. Well, the first thing is it has something like easily adaptable, which is not measurable. But you could put an actual measure in there if you say how much work is it to exchange it. So is it half an hour work?
Do that within a sprint. So somebody implements, how do you actually do that within a sprint? Somebody implements something, they say, I use this pattern to ensure that it's extensible and I can swap out different strategies.
Yeah.
But then how do I measure that? It seems like I can't measure that until maybe 2 sprints later when somebody actually has to do that.
Well, yeah, you're absolutely right. You can't measure the thing when it is implemented, but you will feel it later. But the thing about a scenario is that you can argument if you will reach it or not. And you could imagine that when you implement it and you have the idea that an algorithm is exchangeable within a quarter of an hour or something, you can imagine what kind of abstraction you have to put in there to make it actually work. And
according to some sort of, so once you get your acceptance criteria, we'd say that if it utilizes some sort of standard and adheres to that standard, you can test against that. Then by definition, that standard supports different technologies.
So demonstrate sometimes
To
achieve
be
the standard.
demonstrated not necessarily in terms of that text, but in terms of some sort of standard that fills that text.
so I agree that not every quality requirement is perfectly measurable in a sense that it is implemented and then you know exactly have I reached it or not. This is the goal that we have, but with maintainability it's always hard. What we try to do is to raise the awareness of the team that this topic is here, and then we trust them to do the right thing on this matter. Of course, they could cheat their way through, but that's not the point from distributing and trusting guys that they like to do whatever they want. So this last part where we say be more standards focused, do the common thing or something. This is what we call a principle to be, and this principle to be normally is put into the top of the backlog, because if you define a principle at the end of the project, nobody adheres to it. So potentially the definition of a principle isn't very hard to do. So normally it's from a cost-benefit standpoint, it's pretty easy to put it very high up in the backlog. Acceptance criteria just goes to the story that is already in the backlog, and a quality story is something like this resilient server stuff where you have to work on, but it's an isolated thing that a product owner can attribute value to. So this is something that we try to prioritize on its own.
Is the scenario in the backlog or the activity to actually introduce the architectural
in the product backlog? So the question is the scenario in the backlog or the activity that fulfills the scenario? In the product backlog, we have the actual scenario in there. When we break it down to the tasks that are associated with it, this is the sprint backlog. So this, the actual activity of breaking down tasks, the sprint planning, would then actually filter out the tasks that are necessary. So the third part is the deciding part. So when we have a scenario in there, we've broken down tasks, we worked on it, and we have a solution to propose, then perhaps the point comes where we need to decide if this is the thing that we want to do. And we have two things in there. One is the communication part. We have to in a distributed environment, we have to get architectural ideas to the guys out there, and we have to get feedback in some manner. What we actually use is in these parts that we introduce some technical blogs or communities. Architectural guilds was something that the guy from Invato talked about, which is also something that gets communication going. And this is the foundation how people get actually enough information to incite in an informed way. The second thing is to actually decide. And this decision is something that we try to make by consensus. And this is something that I want to introduce here in a short as an idea. So consensus is a term which describes a general agreement among different members of a group. And this general agreement means that nobody has a veto of some kind. Nobody is against it. It doesn't mean that it's the best thing that could happen to everybody that is in the group, but it's okay for everybody that is in the group. And this is more of a group or a group exercise than a competitive thing that we have with majority voting, where we have different things going in. So to put it perhaps a little more in front, majority voting would be something like democracy. In democracy, you look whoever gets the most votes, and he's the guy you will have to live with for years. With architectural options, it would mean that the majority of guys voting for something would decide where the architecture which architectural direction to go to. And this is a problem if you have a domain like software engineering where we have expertise in very different levels, and actually it's not that common that you have a technical topic where everybody is an expert. In democracy, when we look at normal elections, everybody is an expert on his own life or in his own expectations or moral or whatever. But in software engineering, you have an expert for security. And if the majority thinks it's better to do it another way, and he thinks, well, it would be better to do it this way, and it's a security topic we're talking about, it would be very, well, to put it positive, brave to vote on it and just say, well, you've been overvoted. Or overruled. So consensus tries to put it another way, and what consensus tries to do is that everybody states his things that he's okay with. Somewhere in there is the best option he can think of, and this best option he can think of is something in there, but normally you get a broader thing. A broader scope of things that are okay for you. And a consensus is something where everybody is okay with. So things that you would not be okay with would require a veto. Short example, if we should define where SATURN is taking place next year, people that are organizing it right now would perhaps say, well, it's in Texas. Yeah? Some people in here would be say, well, my preferred location is somewhere else. I don't know, somewhere where you like to do vacation all the time, or your hometown or whatever. So you have another preferred option. But the question is, what is okay for you? And this is something where consensus is very different from voting for your personal best. Which is democracy. And normally consensus is in groups where we work with a very good mechanism to get everybody working for the option. What is very hard in there, nobody can say that he hadn't got the chance to say that this wouldn't work. I don't know if you have these guys in your company that say, well, if you ask me, I said it all the time. This couldn't work and now it happens, so if you ask me, yeah. So this process actually prohibits that. If he has known it from the start, he had the chance to put a veto in and say, well, then we do something else. So there are certain processes that actually try to
To that point, wouldn't
Yes.
consensus be not in the middle then? Would it be between okay and best, but not in the middle?
Actually, to describe this this diagram a little, these are three guys, and every of the three guys has his okay space, and where these three okay spaces meet, this is what they could agree on in this place. Even if the best solution is something that is not the thing we're talking about.
What do you say that consensus focuses on opposition? I think it focuses on reason.
I will have a look at the.
When I look at that diagram, I think about the ones that, number one, that there's an assumption of an intersection between those points on the Venn diagram. And then two, if it is a very small consensus point, then there's also the possibility, and this happens in organizations, where you get these stalemates and then you can't move forward.
Yeah.
Right?
So I exactly agree that this is a picture, and we have to have some process how to get to a consensus. So one thing, a systematic process for consensus is presented here. It's something that we use more often, and it's also something where you get the idea how it focuses on things you don't want to do. What we have actually is that we pose a question. Something like this. And then we have options. So, Palzo, I think, what's called? Plano? Sorry. Plano. Then, of course, we have Vienna. Yeah, and stuff like that. So this would be great for me, actually. And we have like perhaps a third option. Ah. Okay, and what we would try to achieve now is that we have our names put in here, and in this process, you can, if you find something very good, you give it a 0. You have, there's no opposition. If you find something, yeah, whatever, it's still a 0, no opposition. If you go into the direction of actually hating the idea, then you start putting up numbers. So this is the part where opposition score rises. Yeah? And there could be a voting like Plano is already organized, so I guess Bill would say would be great if it would be there. And perhaps everything else is not an option for him. Yeah? And we could have different votes here. So if I would vote, would be something like this. So I kind of like the idea of Antarctica, but yeah. So I don't mind traveling. Yeah? I travel all the time. Antarctica is something that having a conference there, I don't know. The infrastructure is my concern. We have several ideas. We have opposition scores, and what we normally do is that we somehow put a sum down there. Would be more opposition scores in reality, of course, but we perhaps end up with something like this, and this would, of course, say, okay, we have one option that has no opposition there, which is pretty straightforward. It could also be that we say we have no option without a veto. And veto scores is something where we say, in this, normally we say 7 or higher is a veto. So if I put in an 8 for Plano, then 8 is a veto already. So we have an opposition score of 8, which wins this battle here, but it has a veto, so we can't choose this option. We have to talk with me. So the first thing you do is ask me, what could we do to make this option more valuable to you, or what could we change to actually put you back into the picture? So we deal with opposition. That's why the process is there. And this is where we raise concern, risks, all this important stuff. And we focus it on only options that are generally accepted already. So it's a very streamlined process.
How do you limit the veto power? Like it's the same guy who always says an opposition ideas, always vetoes.
Well, the thing is, if you can't decide something, because every option has a veto, you have to put some people to work to actually find a new option. And who is going to be in the task force? The one who has a veto on every option that is here, he has something in his head already, you know? He will be on this task force. Normally guys get tired of this after the third time. So it is a question that's raised very often, but in our projects it doesn't happen very regularly that a guy has opposition scores all the time. So this is something that is pretty okay. I will let you try this process in a break. I will give you in little groups 10 bucks. So I have some bucks, some tens here. So you will get this money and you decide in a group what to do with it. You can do whatever you like, but you have to decide with consensus. Yeah. Okay, we don't have enough time to do it in session here, but just do whatever you like and yeah. So the fourth part is the actual acting. Implementing the idea. And this is something that I don't want to talk about at all because implementing the idea when you decided it is something that is actually easier if there are more people to do it. So the implementation of an architectural idea that everybody agreed on is something that is kind of easy. So the last, one of the last ideas is how is the problem of scale working? All the things I talked about right now work very well in a team of 8 to 10 people. It also works with 3 or 4 teams, but there is a certain scale where this gets very impractical. Everybody talking to everybody, decisions that are meetings that involve like 60 people or something. This is not practical anymore. We try to introduce some roles here. One idea is the architecture owner, which has different names and also different values. If we look at the things that I presented at the start of this session, where I said the architect has different duties and different characteristics, the things that stay with the architecture owner is that he's, of course, a diplomat and he has team spirit and courage and stuff like that. The duties are very important. The duties that stay with an architecture owner are bringing in context, escalating the problems, broaden know-how, coordinate and organize. It's not the decision making or the identifying of risks. This is something that everybody should look at. So the observation part and also the deciding part and everything in the OODA cycle that we saw is actually at the team, and the architecture owner is somebody supporting the team and trying to raise questions, try to bring people together. So if you raise a question and nobody answers, he's the one who listens and perhaps finds a sparring partner for you. So it's more of a sparring partner, a supporting role that we have here. This scales the actual problem to a really big level. We also have a second idea that we sometimes work on, which we call architecture marshals, where we separate the responsibilities for architectural concerns to different guys. So could be per layer. In a layered architecture that we have some guys responsible for UI stuff, some for the backend stuff, or for quality requirements like security or performance. Other than the just like the architecture owner, these guys are normally only responsible for the topic but not deciding all of it. So they try to raise questions about security if they're a security marshal. They perhaps have proposals how to do it. And normally people would listen to them if we have a consensus or something going on and he's a veto on something. Normally people listen if he really knows his stuff, because people know he knows his stuff. So this is another option. And if we look at the factors for choosing such a concept, then we have certain factors that we normally use to determine where to start. In essence, it's a team decision where to go, but this thing where we have no named architect and use some of the topics that I talked about in the last 80 minutes or so, then we start with the approach with a purely cross-functional team. If we have a very big project, not co-located, the business and technical domain is new, then this cross-functional stuff is pretty hard to do, especially if there, I don't know, if you try to make a new project in different locations for the first time with microservices and try to say, well, if you have a topic, just raise it. This would be pretty hard to do. That's when we start with marshals as the idea of certain technical topics are addressed by certain people, also on different locations. So they try to bring people together from different locations. They try to organize meetings or something where people come together and try to support them on different topics. If we have something like an architectural base missing or external dependencies, then we go with the architecture owner. External dependencies meaning that we have perhaps external stakeholders or management that needs a person to talk to. We have certain contexts, normally banks or insurances, where it's not acceptable that they have a team to talk to because they wouldn't invite the team. They want to invite the person, and this person then needs to be somebody. This would be the place for an architecture owner. And the classic architect then would be the option if the discipline within the team is not there, if we have an organizational structure that doesn't allow for an architect that hasn't only the title but needs the position or something. So these are organizational barriers, I would think, that prohibit from going into a more left direction. But normally we get people to one of these three models where decision making stays within the teams. So the teams are actually responsible for what they are building. We talked about the challenges. The two risks are conceptual integrity and the wasteful process. These are two things that are tried to tackle in the last minutes I got here. So conceptual integrity. Conceptual integrity has two modes to us, I would think. The first would be standards first approach. This is the classic architecture approach where we have a phase where we try to figure out how to do it, then we prescribe it, and then everybody does it this way. This is the standards first approach. Something that we try to use in this more community-oriented world is eventual integrity, which is stuff that I just invented. It's like eventual consistency, but on the integrity part, we have different ideas popping up, and we don't try to hinder them from popping up, but we try to bring together good ideas, abstract them, and build an architecture that actually stems from good ideas that we had, and these good ideas will spread, and bad ideas will fail to spread. And we need to find an organizational setup to actually build this kind of organization where good ideas spread through communities, through decision to evaluation workshops, where good ideas actually succeed and bad ideas actually don't succeed because they don't spread. This is something also named low viscosity sometimes. Viscosity is something Robert C. Martin came up with, where he said there's a preferred way to do something, or this a way how this design is actually thought it should be, and this preferred way should be the easiest thing to do. If that's the case, you need much less governance. If people don't do the thing that is easiest, but another thing, they put more effort in it. And if it's harder to do, then perhaps they have a reason for it. And this reason is something else. It's not what do you call it? Because they're lazy. It's another reason, and that's good. Because most of governance processes always tackles the laziness. You want people to do not the lazy stuff. So low viscosity is one concept that we try to use to actually have this integrity part tackled. The other thing is the waste part. Do we have lots of waste in there if we have a crowdsourcing architecture? Because of all of this communication stuff going on, evaluation workshops, decision workshops, and so on. And of course, there is waste in there. There's also things that people often categorize as waste, such as defects from incorrect information. People doing distributed stuff often fail to see the big picture, so we do have errors in there. We have some extra processing in there. What you have to see too is that in practice, some aspects shift that. So if you have delivery speed as an important goal. Delivery speed is something where integrity is. Delivery speed is something where crowdsourcing really pays off. If new technology and innovation is very important to you because you have something a very competitive market or something like this, then again crowdsourcing pays off. And also if you think that your system that you're building is more of a complex nature, so you can't really plan it in advance and then just build it the way you planned it, but you will get new ideas as you build it. Then you have a complex environment like the Knafian framework that was also mentioned today. If you have this idea of systems building, then also it pays off to go more cross-functional because you will have more manpower to actually innovate on this stuff. Also, it is a waste to not utilize the people that you have, which is often forgotten in the waste discussion when we say how to spread architecture. Okay, thank you.